Hi folks, it's Mr. V, and we are on the second half of lesson 15 in the geometry, solid geometry, unit 5 of the Desmos activity. In this one, you were supposed to calculate the volume of the solid, rounding to the nearest tenth. Now, in these activities, the idea was to use the Pythagorean theorem or to use your knowledge of trigonometry, or to use your knowledge of special right triangles, where it's half of a square or half of an equilateral triangle, in order to find out parts that are missing in order to solve these problems. I have this been called up on my whiteboard here. So the three things that you're supposed to be using in this particular lesson, your lesson is, I'm going to give you something that you need to solve, and you don't have all the parts that you need, all the information that you need. So here, the volume is equal to 1/3 the area of the base times the height. Our base is a circle, so that's pi r squared is the base times the height. We need to know the radius and the height. We don't know either. We don't know the height, and we don't know the radius. So we're looking for both of these. We are given, though, it's a right triangle, and it's a 30, 60, 90 right triangle. So if you remember about your 30, 60, 90 right triangles, you can do this in relative short order. The hypotenuse is 10. If my intervention here is for you to draw this 30, 60, 90 right triangle and to write down that the hypotenuse is double the shorter leg, and this would be root 3 times the shorter leg. So with this proportion in mind, you could easily say that this is 5 and that this is going to be 5 times the square root of 3. If you didn't remember this, you might recognize it as half of an equilateral and only know the 5 and this, and you have to find this side. Well, on this side, this is from this angle, 30 degrees. This is my hypotenuse, which is 10. And this would be the adjacent leg. So if I use SOHCAHTOA, and I try to figure out which of these trigonometric ratios to use to find the adjacent when I know the hypotenuse, I'm going to use the cosine. So I could write the cosine of 30 degrees is equal to the A divided by the hypotenuse, which is 10. Multiply both sides by 10, and I get A is equal to, I think it's 8.66. Let's just check it out here. If we do 10 times the cosine of 30, 8.66. So this distance here, which is my radius, is 8.66. We can substitute that in, 8.66 and 5. Now when we plug these values into the formula, we have 1/3 times pi times 8.66 squared times 5. And we'll substitute those values into our calculator. 1/3 times pi, I type it lowercase, times pi, times 8.66 squared times 10. And times 5. And I get 392.7. That's approximated to the first decimal. 392.7. And let me just move this up just a little bit. So you can see it. And this would be in inches cubed because it's a volume. Inches of length measurement, and it takes 3 lengths, a length component, width, and height. Radius times height. And if you plug this into your Desmos, if we plug this in here, 392.7 rounded to the nearest tenth, it gives you feedback, instant feedback as to whether or not you did it correct or not. The next problem that we did was one involving this hemisphere, or half of a sphere. The volume of a sphere is 4/3 pi r cubed. So the volume of half of a sphere would be half of that. The volume of what we have is going to be 1/2 of 4/3 pi r cubed. Well, we need to know the radius in order to solve this volume. And that's what it asks for. What is the volume? We're told that the surface area of a sphere is 4 pi r squared. The surface area of half of a sphere which is what we're dealing with, is 1/2 times 4 pi r squared. And we're told that the surface area is 1. Taking this one square foot of sheet metal, and we're going to press it into the mold until it forms this. Usually use hydraulics, either manually or hydraulic press, to force it in under several inch-pounds of force. So we have 2 pi r squared is equal to 1. To find this, I will do the inverse operation. So I'm going to do divide both sides by 2 pi. And I'm doing this in case that you were absent, or in the case that you wanted to see this done slower than what we might have done it in class. To find out what the radius is, I'm going to take the square root of both sides. So this funky looking number here, square root of 1 over 2 pi, is my radius. I'm going to substitute that back into the equation, plug it into the calculator. Let's see what we get. Let's see, 1/2, because it's half of the sphere, times 4/3 times pi times this value, this square root of 1 over 2 pi, which is some number, cubed. Now let's plug this in and then check our answer, okay? So I'll use my calculator here. I have 1/2 times 4/3 times pi times parentheses square root of 1 divided by 2 pi, close parentheses, cubed. And I get 0.133, 0.133. And this is going to be in feet cubed for the volume of this. Not very much. Maybe, how much is 1/10 of 1 cubed? That's maybe a quarter or something. I don't know. We'll find out. Let's see if this is correct when we substitute in the value here. We had 0.133. And I submitted inches. This should be inches cubed. And it is correct. So there's that. Oops. I just wanted to do this. I want to look at the student preview. And we're going to go to several pages further. We started this on page 10. Well, now we have the volumes of a rotation. And if you wanted to see what this looks like, I do have a GeoGebra applet here, which will help you, if I can get it to call up, to see what this looks like. Notice my distance here from 4, 3, 2, 1. That's a distance of 3, and a radius of 2. And this is a distance of 5 and a radius of 2. And when you rotate this, here's what it looks like. You can actually look at this in 3 dimensions. You can see, oh yeah, this is going to be a silo. That's what it is. It's got a cone on the top and a cylinder on the bottom. And if you were to do this on your paper, which is what I asked you to do today, you would draw a circle here and dotted lines and a circle up here. And you can see that this is a composite. It's made up of a cone at the top and a cylinder at the bottom. So if I'm going to do this, I need to know the volume of a cylinder, a volume of a cone, first of all, and the volume of a cylinder. So the volume of a cone is 1/3 the area of the base times the height, and the base is going to be pi r squared. 1/3 times pi r squared times the height. And then for the volume of a cylinder, is equal to the base times the height, which is pi r squared times the height. Now, the radius of this top piece is 2. The height is equal to 3. We start here, we go 1, 2, 3. The radius of the bottom part is 2, and the height is 5. So now we'll substitute the values. We have 1/3 times pi times the radius squared, which is 2 squared, times 3. And 3 times 1/3 is going to cancel these two. I'm left with 4 pi for the volume of the top part. The bottom part, we'd substitute the values. Pi times 2 squared times 5. 5 times 4 is 20. So this is going to be 20 pi. And when you add these two together, this will give me a total of 24 pi cubic inches. 24. And that's going to be approximated when we stick this into the calculator. We have 24 pi, and we get 75.4. It's about 75.4, and this is cubic inches. This might be a model of what you would be getting in a real silo, or maybe it's for a kid's toy or something. I don't know. 75.4, and we plug this into the Desmos. If I can call it the Desmos, and we go down here. Let's see where's the next page is where we actually put this in. We do 75.4, and maybe it will give us a thumbs up. It doesn't. Okay, so I need to fix this page to give you instant feedback. Some of the questions to ask. What are the dimensions needed to calculate the volume of a cone? It's pi r squared times h times 1/3. So you need to know the radius and the height. What formulas are used when calculating the volume of a triangular pyramid? This is interesting, and I'm going to show you here because it's that interesting. If I have a triangle, let's just say it's a right triangle like this. I should make this a right triangle like this with a dotted line in the background. This has a height and it has a base. The area of this piece is going to be 1/2 of the base times the height. For it to be a pyramid, it has to go up to a cone, to a peak. So the volume of a pyramid is equal to 1/3 times the area of the base times the height. The area of the base is the area of our triangle, which is 1/2 of the base times the height, times the height. What's the difference between this base and height and this base and height? Well, this is the base of our triangle. This is the height of our triangle down here. This is the height of the pyramid. So it's going to be this distance here, this height of the pyramid. This base of the pyramid is this area. It's this whole area. So that's the difference between those two. Very important. Let's see, what else do we need to ask? What's the volume used in calculating a cylinder? Pi r squared times h. And then there's this last problem for you to do. And since I've spent so much time already talking about this, I will go ahead and show you this. Brand A is in the shape of a cone, like this. This is 1/3. Volume is equal to 1/3 times the area of the base times the height, which is 1/3 pi r squared times the height. The second one is going to be in the form of a prism, a rectangular prism, and you're told that the sides are 5 and 5 and 2.5 because it's a square on the bottom. The volume of this one is equal to the area of the base times the height, which is length times width times the height. So here we have 5 times 5 times 2.5, which is 62.5. This would be centimeters cubed. And to compare it to this other one, we actually have to substitute the values and solve. 1/3 times pi times the radius, which we are told is 2.5 squared, times 10. And we'll substitute that into the calculator. 1/3 times pi times 2.5 squared times 10. Oh, it's 65.4 when I round it to the nearest tenth. 65.4 centimeters cubed, which means that it has the greater volume. So this one is the bigger volume for the cone. Folks, good luck and success.